All right. In the series of our lectures for biomechanics/movement science, we are at the second lecture. Not the lecture, just a small, presentation, which is geared to help people understand these concepts in a more simplified way and in a short video. Okay. So today we're going to talk about kinetics here. All right. So, kinetics is basically the science concerned with the analysis of the forces. So, basically, what we do here is what we talk about analysis of forces. So, we talk about forces here. That's the main concept here. Okay. In kinematics, if you remember, we talked about motion, and here we talk about the forces. So, we need force for motion. Okay, and this can be seen in the in this equation here, that is Newton's second law of motion, that for F is equals to ma, which basically shows that if the mass is constant, okay, then the force applied is directly proportional to the acceleration produced. Okay, so that is, force is basically the impetus of producing motion. So force is measured in Newton, and that's how the relationship between force and acceleration is perceived, derived from the Newton's second law of motion. Now, when we talk about human kinetics, we divide it into two main forces. One is external, and one is the internal force. External force, primarily, that is all the time acting in your body. That's your trivia question. What is the force that is acting on your body all the time? That is your gravity. Okay, so gravity is the pull that is all the time acting in your body, and it is pulling you downwards towards the ground. Okay, so let's see here, like we have an elbow flexion example here. Forget about these numbers. We are not going to talk about them right now, but maybe in the future. But if you look at that, we have this force of gravity that is acting here, and then we also have the external load here. Okay, so external forces can be gravity, external load, or weight that you are carrying. Okay, so these are some of the forces that externally are acting on the body, and these forces are counteracted to maintain the equilibrium by internal forces, and the internal forces primarily are your muscular forces. Okay, so just to mention here that it's not only the muscles, your connective tissue, your ligaments, your fascia, all are playing a role to counteract gravity. Otherwise, think about that you, when you stand, gravity is pulling you down. But why are you standing and maintaining your erect posture? You are maintaining your erect posture because your body has the mechanisms to produce internal forces to counteract gravity, so that this goes into an equilibrium state that you can maintain. So we talked about forces, we talked about kinetics, we talked about external force, we talked about the internal force here. Okay, now force is usually represented by a vector here. Okay, so this vector that is used to represent force is, for example, this one here or this one here. This vector is primarily giving you, it has, sorry, my drawing is really bad. It has, the vector has a length, okay, and it has a direction. So this length is basically the magnitude of the force, and this arrow is pointing towards the direction of that force. Okay, so that's how the arrow is represented here. So like, for example, you can see here that you have gravitational force, and then you have the load, that are both counteracted by this force here. Okay, by the force of the muscle here. Okay, so these are some of the important concepts here. Now we'll go towards another important concept that is called SCOM, that is your center of mass. Okay. Center of mass of any structure is that point where your that body is in equilibrium position, like that typical example of seesaw, that you guys know, from your basic physics class, that this point was called the center of mass, where where the seesaw was able to balance itself, this is that point, where you maintain the equilibrium, or you reach the equilibrium here. Like for example, here you can see that this baseball bat is balanced at this position, this crutch is balanced at this position, and then you have the ball that has a center of mass here. Similarly, human body has a center of mass. Human body center of mass is usually located here, where my marker is, like that is your S2. S2 is your second sacral vertebrae. That's where your center of mass is located. However, this keeps on changing. Okay, this can be changing for multiple reasons. For example, this person here is carrying weight on his shoulder. So when they're carrying weight on his shoulder, a lot of their mass has shifted up towards their body. Okay, so that's why their center of mass is shifted upwards. It was S2, but now it is somewhere at T4, because you can see that it's almost at their thoracic region, and at their nipple line, that is your T4 vertebrae here. So that's how the center of mass changes. In center of mass is also higher in children. If I draw a child here, for example, it is it is above the S2. The reason for that is that they have bigger head, and for that reason, when the mass is mostly concentrated on the up body, then that's your center of mass shift here. Okay, so these are most of the concepts about forces. Now you have learned about kinematics and you have learned about kinetics. Now we'll go towards the interplay of these kinetics and kinematics, and that we call as principles, that we'll discuss is in the principles of human motion or human mechanics. Thank you.